Start seeing it go.
When it starts to roll is actually when the time starts, is the rules.
Ready?
Yep.
So again, Frank's following the left hand. It's like as if he has his left hand out following along the walls of the maze. Of course, the walls here are imaginary since we have lines. And when he gets to a dead end, he turns around. I'm going to guess that Frank has software that will detect that he has turned left, turned around, and gone back and turned left again, and knows that that's a dead end. Is that correct? And so, on his subsequent runs, he will not turn left at that particular intersection. So he is keeping track of every intersection that he goes down, and then his software will attempt to eliminate any extra travel. Our maze was also designed specifically so that these simple left-right reduction methods do not actually find the optimum path through the maze. There's a little bit of extra challenge there because that's what we do. Turning around, all right. So far, Frank's robot is doing exactly as expected.
On the left hand.
And we have our first solution now. And a time of?
151.25.
151 and a half. All right. So hopefully this isn't too much like watching grass grow.
Ready?
You're going to do the opposite hand this time?
Right hand.
You're going to do right hand this time. Excellent. When the officials are ready?
Yes.
Okay. So the exciting part is going to come on Frank's third round whenever he will be attempting to eliminate all of the extra dead ends. And is the robot going to run a little bit faster? Or are you going to go at the same speed?
It'll be the same speed.
Same speed, but should be much less time because it won't take as many of these extra
But this is
tabs.
tricky. This is a complex maze.
It is yeah.
You never know. It's doing all right turns.
We're doing all right turns now.
And every time it makes a turn, it's already eliminated. Right now, it's just eliminated that branch. So
Right.
next time, it should bypass it.
We're going down a long dead end with a bunch of zigzags, but now I'm going to presume that your robot will automatically decide whether the left rule or the right rule was better.
I have it so that you can select which one. It'll tell me which one.
But it'll tell you which one.
It'll tell me how many steps in each one.
All right. So that Frank's robot will tell him which is the fastest route, and then we'll follow that route. Here we go. Last two turns. Excellent run.
Okay.
126.
126. And now the money run.
All right. It says the left is 41, and the right is 25.
So the right is the winner of this particular maze. And we're ready to go. Calibrate and launch. Taking a nice conservative pace. And look at that, eliminated that dead end. That's excellent. But, oh, well, because of the loop, it would require some extra software to determine the loop because it's not just eliminating a dead end, because it's a loop and not a dead end. A little bit tricky there.
Trick will be if it gets rid of the other snake at the other end.
Right. So we expect it to turn left here, and it does, and we expect it hopefully to turn left here. Excellent job, Frank. So we have eliminated all the dead ends so far except the loops. Last two turns coming up on the end. Timer's ready. All right.
46.
46. So that is half, less than half the time. Less than half the time to solve the maze after knowing the software. Ready when you are, Dale.
Okay, timer ready? Yep.
The interesting thing about this is you have to follow the line perfectly. There is no room for error. If you zigzag off the line, then you might miss an intersection, and you miss an intersection, then you really have no idea what the maze actually looks like. So, taking that long zigzag dead end. Oh, let's go back. The size of the maze, the spacing of the lines is all published in the rules, so that you know how big you need to make your sensors and time.
40.76.
40.76. So cooking along pretty quickly. And now we're going to do the left hand, I presume?
Yeah.
All right, we're going to check the left-hand path. Now, Frank's robot found the left-hand path was slower. However, Dale has, we believe, some more advanced software that will eliminate loops. Is that true? That's the hope. The hope is that it will eliminate the loops and therefore have an advantage. Oh my goodness. That is totally unexpected.
Always something.
There's a washer up down there too as well.
The screw that held this thing on fell off.
Oh wow. We're going to take a few moments to get let Dale do a repair here. In the meantime, you know.
What are you doing over there?
Warbling, I didn't get it on. Messed something up. Try to use it.
No, this one's not running today. This is on the wheel. I tried powering up a little bit, but for some reason I had a problem. I'm not sure if we what. I still want to bring you one show. It's got a little different kind of a this one's wild. This one's running. This one still has one. Probably have one. This one here.
Yeah, it's got claws on there. Probably not be black tape. I gotta be careful with the claws.
52 seconds.
Tuned to the max, huh?
Yeah, supposed to be.
All right.
This should be the alpha.
All right.
Yep.
You ready?
We need to wait for Frank to clear here. Have a little bit of a race here for the final. You'll notice that he did not take the loop. Did not take the loop. And we have taken the shortest path. Wow. Very excellent.
14.6.
14.6. 14.6. By the way, so congratulations to Dale because we have been running Maze for 3 years. This is the first time in 3 years that anyone has successfully completely reduced the maze with all loops removed. So, all right. So Frank did an awesome job reducing the maze, however, having the loop in there, and but excellent. 14 point what?
14.62.
14.62.